Question number 71. Equilibrium concentrations of A and B involved in the following equilibrium are 0.01 molar and 0.02 molar respectively. And what is the reaction that's taking place here? It's A. It's getting changed into B. It means equilibrium is there. And if 0.01 molar of A is added at equilibrium, then at new equilibrium concentration of B will be. Now, the concentration of A at equilibrium is 0.01 molar. This is at equilibrium. If we talk about concentration of B, that is 0.02 molar. Now, with the help of this, we can find out the Kc value. That is equal to the concentration of B at equilibrium divided by concentration of A at equilibrium. And the value for this Kc is 2 here. That's it. Now, after this, what we are going to do here, you are just going to add this 0.01 molar of A to the reaction mixture at equilibrium. Now, in the second condition, what you did, if 0.01 molar of A is added at equilibrium, it means amount of A that is further added to the reaction mixture is 0.01. And now, in second condition, the amount of this A becomes 0.02 because previously it was 0.01 and now you have added 0.01 again. Now what about B? If we talk about this B, its amount is initially 0.02, but what you did, you have just assumed that some more amount of B is formed. And now let's assume at equilibrium the amount of B is 0.02 plus X. Let's assume that X amount of B is formed at equilibrium while the amount of A at equilibrium would be 0.02 minus X. Now with the help of this we can find out Kc for this. We know that it can be calculated using the concentration of B divided by concentration of A, and we already know that the value of Kc is 2. Now it's your turn. Just solve this for the value of X. And if you solve this for the value of X, it is 0.00667. This would be the value of X. And if it is the value, you can easily find out the amount of B at equilibrium. So the concentration of B at equilibrium is equal to initially present 0.02 plus 0.00667. So this value would be 0.02667. Where this value is given, if you check the given options, you will find out that this value is given in option 2 because it can also be represented as 2.67 into 10 to the power minus 2 molar. So this is the correct answer, and that's why option 2 is the correct option for this particular question. Let's move on to the question number 72. Question number 72. Select the correct option among following at 298 Kelvin temperature is. We have different options given here, and I just want to make it clear that whenever we talk about the neutral solution, always H plus ion is equal to the concentration of OH minus ion, that is equal to root of Kw, ionic product of water. Further, if we talk about, this was for neutral, if we talk about acidic aqueous solution, then in that case this concentration of H plus ion is more than that of root of Kw value, while in case of basic solution the concentration of OH minus ion is more than that of root of Kw value. With the help of this we can easily choose the correct option from the following. And if you check the given options, you will find out that correct expression is given in option 1. And if you talk about the fourth option, in basic aqueous solution pH is less than POH, it is also wrong. Only the first option is correct. And that's why the correct answer for this question is also option 1. Now let's check this next question. Now question number 73, in which of the following equilibrium Kc is equals to Kp? We should always know that the reaction for which this delta Ng value is 0, then definitely this Kc value is equal to Kp. Why? Because Kp is equals to Kc RT raised to the power delta Ng, and if this delta Ng value is 0, this whole expression becomes 1 and Kp becomes equal to Kc. Let's check the first reaction in which the value of delta Ng is 0, because 2 gaseous moles are here, and here if we talk about reactant side, 2 gaseous moles are there. It means delta Ng is 0. While if we check other reaction, it is not so. That's why first option is the correct option for this particular case. After this, it's the turn for next question, that is 74. Question number 74. If equal volume of 0.1 molar ammonium hydroxide and 0.1 molar HCl are mixed, then the pH of resulting mixture will be. We have the given value of pKb for ammonium hydroxide, that is 4.75, and log 5 value is 0.7. So in this particular case, you are mixing the equal volume of these two. One is a base and other is an acid, and these two are mixed to form ammonium chloride. Along with that, water is also formed. Now in this case, we have the 0.1 molar concentration of ammonium hydroxide, with the help of which we can find out the moles of ammonium hydroxide. Let's assume that V volume of this ammonium hydroxide is taken. So definitely the moles which are present initially of this ammonium hydroxide is 0.1 volume. Further, for HCl, the same moles would be there, 0.1 V, because equal volume is taken, and this is 0. Now, final mole, the moles of ammonium hydroxide become 0, moles of HCl become 0, but if we talk about ammonium chloride, its moles would be 0.1 V. Now, the question is there to find out the concentration of ammonium chloride. So if we talk about the concentration of ammonium chloride, that would be equal to moles of ammonium chloride divided by the total volume. That total volume becomes V plus V, that is 2V, and that's why the concentration of ammonium chloride would be 5 into 10 raised to the power minus 2. Now, what would be the pH for the resulting mixture? That would be equal to 7 minus half of the pKb value minus log C. This would be the formula using which we can find out the pH of this salt. So we have 7 minus half of, what's the pKb value? That is 4.75 minus log the concentration of the salt. That concentration we have just calculated, 5 into 10 is to the power minus 2. And if you solve this, you will find out the value for this would becomes 5.2755, and that is approximately equal to 5.28. And on the basis of this, I'm just going to choose the fourth option as the correct option. Now after this, let's move on to the question number 75. Question number 75. Equal mass of oxygen and helium gases are mixed in a container at 27 degrees Celsius. Fraction of total pressure exerted by helium gas is. It means in this question we have to just consider that both of these gases have equal mass and they are mixed in a container, and you just have to find out the fraction of total pressure exerted by helium gas. We should always know that whenever we talk about the pressure exerted by a particular gas, that is equal to the mole fraction of that gas into total pressure. Now, if we talk about these two gases, we have two gases, oxygen and helium. We don't know about their masses. Let's assume both of these gases have the mass x gram, and if they have the x gram mass, then moles of oxygen would be equal to the given mass of oxygen divided by its molar mass. What is that? That is 32 gram per mole. So I'm just going to divide it by 32. So these are the mole of O2. Now what are the moles of helium? Those would be X by 4 mole. Now we just want to find out the fraction of the total pressure exerted by the helium gas. It means we have to take the mole fraction of helium gas, multiply it by the total pressure to find out the pressure exerted by that particular gas. So in this case, let's assume total pressure be P, and in that case the pressure exerted by helium, that is He pressure, I'm just assuming, that is equal to the mole fraction of helium, that is X by 4 moles of helium divided by total moles, those are X by 32 plus X by 4 into total pressure, that is P. We will find out that it is 8 by 9 P. It means if P is the total pressure, its 8 by 9 fraction is the pressure that is exerted by helium gas. And where it is given in option 2, and that's why the answer for this question is option 2. And it's a turn for question number 76.